Okay, here we go. It says, answer the following questions about the function whose derivative is. They've done you a favor on these first few problems. They actually give you the derivative. F prime of x is equal to x squared times x minus 4 over x plus 6. Okay, first part it says, what are the critical points? Reminder, critical points are anywhere the derivative is equal to 0 or anywhere the derivative is undefined. So on this one, what makes it equal to 0? You can say equals 0. What's going to make this fraction equal to 0 is the top being equal to 0. So we're going to come down here and say that x squared times x minus 4 is 0. Or the thing that's going to make it undefined is if the bottom's equal to 0. So we're going to also set x plus 6 equal to 0. This is going to be all your critical points. Setting each of these equal to 0, you're going to have x squared is 0, which is going to give you x is 0. You're going to have x minus 4 is 0, which gives you x is 6. X plus 6 is 0. It's going to be undefined at x equals negative 6. So that's your three critical points.
Shouldn't the middle one be x equals 4?
It sure, yeah, where'd that come from? X equals 4. It's early. Okay, it says, on what open intervals is f increasing and decreasing? Again, reminder, this is critical points. These are possible maximums and minimums. So if you have a maximum and then it starts decreasing again, these are the places where you can change from increasing to decreasing. So again, what do? You check negative 6, 0, 4. You check the intervals in between to find out, is my function increasing and decreasing? And this is where I missed the problem yesterday. Make sure that when you're checking for increasing or decreasing that you go back to your derivative. You go back to the slope function, because knowing whether the slope is positive or negative, if the slope is positive, we know it's increasing, or if the slope is negative, we know it's decreasing. So let's check, again, pick any numbers, negative 8, maybe negative 3, 3, and 6. And plug those into your original function. So plugging negative 8 gives us 64 times negative 12 over negative 2. We're not real concerned about what this number is. We're just concerned with, is it positive or is it negative? Positive times negative is a negative over a negative is equal to a positive number. Don't go through the process of actually working it out. So in this, since our derivative is positive here, that means our function is increasing. We can plug in negative 3 and do the exact same thing. Negative 3 squared is 9. Negative 3 minus 4 is negative 7. Negative 3 plus 6 is 3. So we have 9 times negative 7, which is a negative 63 over a positive. Negative over a positive gives me a negative, which means my function is decreasing on that interval. Let's go ahead and do the other two. 9, negative 1, and 9. Negative over a positive gives me a negative, and also 6 would be 36, 2, and 12, which is obviously a positive. So we're decreasing on this interval and we're increasing on this interval because, again, my slope was negative, my slope was positive. So what's actually happened here, we have a, let's see, C part says at what points, if any, does f assume a local maximum or a minimum value? If we're increasing and then we start decreasing, from what we learned yesterday, that's obviously going to be a local max. And if we're decreasing and then we start increasing, that's obviously going to be a local min. It says again, f prime of x on this one, f prime of x is equal to sine of x plus 1 to cosine x minus root 3. Now, we know that sine and cosine are both periodic functions, and this would have so many possible critical points and local maxes, local mins. So they're going to have to give you an interval on these. They say from 0 let's see, that x value is between 0 and 2 pi. Do not worry about any of the other ones. Just stay between 0 and 360 degrees so that we don't have infinite answers. I want to point out again that this is f prime, that they don't give you original function, and they do this on several of your homework problems. They give you the derivative, and then they say go from there. So first thing they ask you for is critical points. And again, we know that your critical points is anywhere the function is undefined or anywhere the function is 0. Or anywhere the derivative, excuse me. So here, we know that sine is defined everywhere. It's periodic and it goes forever left and right. So is cosine. It's a wave. So we don't have to worry about where they're undefined. We only have to worry about where they're equal to 0. So we set the whole thing equal to 0, and we get sine of x plus 1. You're going to split it. If this is equal to 0, then one or the other has to be 0. So sine of x plus 1 is 0, or 2 cosine x minus root 3 is 0. So either sine of x is negative 1, or cosine of x, add root 3, divide by 2, you get root 3 over 2. We've got to solve these trig equations. So we want to know, first off, where's the sine of x equals negative 1? Reminder, we're only worried about 0 to 2 pi. We don't have to give every answer. So the sine of x is negative 1. I know that from my unit circle that sine is positive 1 here. Sine is 0 at 0 and 180, and negative 1 down here at 270 degrees. And since we're in radians, 3 pi over 2. So that's one critical value. Cosine is positive. We're actually going to have two answers for this one because I know that cosine is positive here and here. And I know that the cosine, my reference angle there, we'll do it in degrees first. Cosine is equal to root 3 over 2 at 30 degrees. So that's my reference angle. So I'll have another one down here with the same reference angle at 330 degrees, which would be in radians, pi over 6 gives you that 30, or 11 of those would give you 330. So that's all my critical values. 3 pi over 2, pi over 6, and 11 pi over 6. Next part says, tell where the function is increasing and decreasing. So again, we check our critical values. And all you've got to do is plot those critical values. Make sure they're in order. Let's see, pi over 6 will come first because that's 30 degrees. This 3 pi over 2 is 270 degrees. That'll come next. And 11 pi over 6 will come last. And again, you can check these critical values on a graph. Okay, you can see, you can graph this, see what's happening at these different critical values, and that's going to tell you from your graph whether it's increasing or decreasing on each side of these. But the other way you can do it is you can plug in values in this domain. Can't be outside of it. There's your domain again, 0 to 360. So I'd plug in maybe 0 and see what's happening there. You got the sine of 0, which is 0 plus 1, which is 1 when you plug in 0. Cosine of 0, which is 1. 2 times 1 is 2. And then you have 2 minus root 3. The square root of 3 is less than 2. Oops. The square root of 3 is less than 2, so I know when I do 2 minus the square root of 3, I'm going to get a positive, and that's all I'm concerned with, is it positive or negative. So in that interval, we know that we're increasing. My graph's going up. Plug in something on the other side of it. Okay, again, this is 30. If you'd rather do this in degrees, it's okay. 30 degrees. This was 270 degrees. And this was 330 degrees. And since you're just finding the sine and cosine of them, it really doesn't matter if you're in degrees or radians. So what I would do is plug in something maybe, let's see, between 30 and 270. Think about it and try to come up with something that would be easy to plug in, like 180 degrees. That's in that interval. And the reason 180 would be easy to plug in is because we know that the sine or cosine, well actually the sine of 180 is 0, so that's going to be a little bit cleaner. And the cosine of 180 is negative 1. So you got sine of 180 is 0 plus 1, So let's plug that in. 0 plus 1 is 1. The cosine of 180, which is negative 1, so that'd be negative 2 times negative, or excuse me, 2 times negative 1, which is negative 2, minus root 3, which is obviously here negative. So 1 times a negative is going to be a negative. So my function is decreasing on this interval. And then again, plug in something easy. Unfortunately, between 270 and 330, there's not anything real easy. Let's go for 300 degrees though. So here we go. Plug in 300 degrees. Again, I'm only concerned with, is it positive or is it negative? Is it increasing or is it decreasing? Sine of 300, we're thinking reference angles there. That'd be negative root 3 over 2. Because your reference angle would be 60, it's in the fourth quadrant. So therefore, it'll be negative since it's sine in the fourth quadrant. It'll be root 3 over 2 since your reference angle is 60, plus 1. Now let's stop and think about this. Root 3 over 2 is negative. Now the question is, simply, is this positive or negative? We're not real concerned about what it's equal to. I'm only need to know, is it positive or is it negative? If you need to type it in and find a decimal for it, that's fine. But the square root of 3, it's less than 2. It's about 1.6. If you do 1.6 and divide it by 2, you're going to get something less than 1. You're going to get like 0.8. So negative 0.8 plus 1, that's going to be a positive answer. That's all you're concerned with. Now here, again, we're plugging in 300. Cosine of 300, you have 2 times. Cosine of 300, you're in the fourth quadrant. And if you don't remember, all students take calculus. Since you're in the fourth quadrant, we know that cosine is going to be positive. You get the cosine of 300, which has a reference angle of 60. Cosine of 60 is a half minus the square root of 3, and that'll be pretty easy. That's 1 minus root 3. I've already told you that root 3 is about 1.6 maybe, so 1 minus something bigger than 1 is going to give you a negative. So you have positive stuff times negative stuff, which gives you negative stuff. So we know that we have an increasing function from 0 to pi over 6. We have a decreasing function from pi over 6 to 3 pi over 2. And then it continues decreasing from 3 pi over 2. So I think the last part of it was, where is it increasing or decreasing? We found that. At what points, if any, does f assume a local maximum or minimum? If it's increasing and then starts decreasing, then we have a max here. If it's decreasing and then continues to decrease, then there's no max or min here. Now we do, well, I forgot to check this last interval. You can plug in something bigger over here at 11 pi over 6. I'm just going to save us a little bit of time and look at my graph here. Let's see, it was positive, negative, negative, and at this point it's going to be positive, so you see that you're going to actually have a local min there. Anywhere it changes from negative and then positive, decreasing and starts increasing, you're going to have a minimum right there. The last one's on your homework, where you're given functions like this. Pretty much it's do the exact same thing after you find the derivative. The only difference between this problem and the problems we worked before is you're given f of x. You could actually graph this and look and see what's happening. But first step, you would actually find the derivative. And reminder that if you have x stuff times x stuff, you do have to use product rule. So you're going to do here first times derivative of the second. Derivative of natural log of x is 1 over x. Plus the second times derivative of the first will be natural log, 3 times natural log of x. Here the x's are going to cancel, leaves you with just 3 plus 3 natural log x. That can be factored because we're wanting to know where is this undefined and where is it equal to 0. So let's set it equal to 0. Solve it by factoring out a 3. You have 3 times 1 plus natural log x equals 0. You can divide by that 3, the other side, and you're going to get 1 plus the natural log of x is equal to 0. Move the 1 over. You get the natural log of x is equal to negative 1. I wanted to work this one to where I could remind you how to solve logarithmic equations. Once you get to this point and there's nothing else that I can move over, the only thing there is to do is to solve it by changing forms. This has a base of e, so we're going to write this as e to the negative 1 power is equal to x. That's your solution. So we know that the only place where this graph can change from increasing to decreasing is at 1 over e. And you can do, that's 1 divided by 2.718, and you can type that into your calculator if you'd like, and see, let's get a rounded answer for that. So what we can do, since 1 over e is about 0.4, the reason I just, 1 decimal place was plenty, is I just needed to know what to plug in on each side. I can plug in a 0. No, I can't, because I can't take the log of 0. I can plug in like a 0.1, and I can plug in like a 0.5. And let's just do this. Let's just type that straight into our calculator. 3 times 0.1 times the natural log of 0.1. We type it in, and again, I'm only concerned with is my answer negative or positive, and somebody else do this for me. 3 times 0.5 times the natural log of 0.5. Type those in. Tell me, do you have a positive answer or do you have a negative? Listen to this. Make sure when you're plugging these values back in to find out if it's increasing or decreasing. This is the biggest mistake that I make, and you just saw me make it again. Make sure that you plug in these into your derivative, because your derivative is what's going to tell you if it's increasing or decreasing. Your derivative tells you if it's slanted up, if your slope is up, or if your slope is negative. So here's where we're concerned with. So when you plug in 0.1 into this, does anybody get a negative? Should get a negative there and should get a positive here. So what does that mean? It's decreasing everywhere in this interval, so it's going down. And then at 1 over e, something happens and it starts going up. This has to be a local minimum. And you could actually look at the graph, and that's the only local minimum, and you don't have any asymptote lines, or you don't have your graph going to infinity or anything. This graph kind of looks like a parabola. It starts here at 0. Well, it's an open circle at 0. And it comes down, and then it starts going back up. That's what this graph looks like. So here you see that 1 over e is not only going to be a local minimum, but it would actually be an absolute minimum as well.